So I recently received a number of questions about using MIDI to control software and hardware. So I thought I'd do a series of tutorials about using MIDI to make it a little bit more easy to understand. So what we're taking a look at here is the back of an older lighting console. And I used to use one of these. It's an ETC element. And you notice that it has a MIDI in and out port. This particular lighting console was able to receive MIDI messages that would make it act upon cues. I could be using my show control to play back audio cues and also possibly to play back video or run PowerPoint slides. At the same time, the show control software would send MIDI cues to this light board to progress through my light cues. So that way everything could be synchronized together. Now, as far as the command set, there was a limited command set as far as what MIDI cues it would understand. And it's going to be different for every single piece of equipment or every piece of software. Depends on what the manufacturer has enabled in the terms of MIDI. This particular console had a substantial amount of MIDI cues that it would understand, but primarily what I used it for was to progress from cue to cue when I was doing a show. Here's a audio mixer, an Allen Heath ML3000 that I also used to use. This particular mixer was able to record mute settings, and it would be able to record up to 100 different mute settings. So if I was doing a show that was microphone heavy, like for example, I might be doing a show that might have 28 wireless mics, instead of me having to manually turn off and on those 28 mics, I could send it a MIDI information, some kind of MIDI information code like a note on, note off, or a program change, and it would progress through those different mic settings, and it would actually memorize the different mic settings. So it made it a lot easier to go through and produce a show. I didn't have to manually turn mutes on and off. I could do it remotely, sending MIDI codes in, and it would do all the mutes at one time. So it made it a lot easier, especially in producing shows that were using a lot of microphones. Here's a modern Behringer digital mixer. They still have the MIDI input and output on it. Interestingly enough, the Behringer not only understands MIDI codes to do certain things, but it also is capable of sending out MIDI codes. So you could actually send out MIDI codes that would control a lighting console or lighting software from the Behringer mixer. And vice versa, you could send MIDI codes into the Behringer to make it turn channels on and off or adjust volume levels or bring up certain cue sets and that. This particular mixer is a lot more advanced. Not only would it memorize mute on and off settings, but could do total different setups as far as what instruments, what microphones, and what channels. So very, very advanced. I have to say though, that a lot of the newer mixers, they're abandoning using the MIDI so much, and they're using OSC, Open Sound Control. That has become a more popular format because you can send more data using Open Sound Control than you could with MIDI, even though you can do a lot with MIDI. Here's an older MIDI controller that uses the old 5-pin in and out. Now you can use something like this, which is a hardware controller, to actually send MIDI signals to a lighting desk or a sound desk or something like that. You could send signals to QLC Plus software using this. Now more traditionally, or today, most of the modern hardware MIDI devices like this just simply use a USB cable coming in, goes right in your computer. But same thing, you could use this Akai MIDI mix to send signals to QLC Plus or to some other kind of lighting desk or sound desk that would accept MIDI channel information. So, and finally, I used to have actually a hardware hookup, so I had a show control computer, and then I would use a USB port, and then it would send out, these are 5-pin cables, and I could send a message to my light board, and then that message could also be sent through from the light board over to another computer that was running PowerPoint slides. So my show control computer could be playing back my audio cues and sending MIDI cues to my light board and to my PowerPoint presentation. And possibly I could go also to a video projection system where another computer is putting up video projection slides. If my show control computer doesn't have video built in, I can have video projection going on another computer and control that using MIDI. So MIDI can be used extensively for a lot of control during a show, just to make things a lot easier for you as far as automation goes. Now, a little bit about understanding about MIDI and how that works. MIDI is basically a language of 127 digital commands, or numbers if you want to look at that. It uses a code of 0 to 127. Sometimes you see this listed as 1 to 128, but it's basically 0 to 127. And they use a hex code to accomplish this. So they only need a number or two numbers or a number and a letter to get up to the 127. So it's binary. And you need to understand a little bit about MIDI hexadecimal codes sometimes to get yourself out of a jam and understand what's actually going on with a MIDI situation. So here we have this hexadecimal conversion table just to show you that. So the number 0 is represented by 00, 1 is 01, and as you progress down here, we get to 9 is 09. Now here's where the hexadecimal comes in. 10 is represented by 0A, 11 is 0B, 12 is 0C, 13 0D, 14 0E, 15 0F. Now we'll go back. So 16 actually represents the hexadecimal number 10. So this is where it can get confusing. So again, we'll go 1 through 9 or 10 through 19, and then we use A, B, C, D, E, F again. Then we do in the 20s, 20 through 29, and we use 2 A, B, C, D, E, F, and so on. So our minimum number would be 0, and our maximum number would be 127, which is represented by 7F. Okay, so again, you can use binary to accomplish this 127. So it's similar to DMX uses a language that's 0 to 255. MIDI uses a language that is from 0 to 127. So this is what your hexadecimal conversion table. Why do you need to know this? We're going to show you in a minute. Another thing you need to know is MIDI was basically invented as it's a musical instrument digital interface. So it's basically invented for electronic keyboards and devices to be able to talk to one another and to talk to software and to talk to computers. So it was established as a basic language. So now that we're talking about music, we also have to have notes involved here. So this is something that's a little bit crazy to understand too when you're doing MIDI. So think of a piano keyboard where you have 88 keys on it, and we have to represent those 88 keys with all the different notes, C, C sharp, D, D sharp, E, F, F sharp, G, G sharp, A sharp, B, and then we're back to C in what we call another octave, if you remember any of your music theory classes. Anyway, when we're looking at sending MIDI note off and on messages to a device, you've got to keep in mind what particular MIDI note you're sending so that you don't get lost in the transfer of information here. And this can get a little confusing because some manufacturers will look at this a little bit differently. This chart, for example, if we're talking about C0, that is here. So that would be 0, C sharp is 1, D is 2, D sharp is 3, E is 4, and F is 5, and so on. So when we look at MIDI note number, let's say D1, which is 14, the number 14 isn't really sent. It's the hexadecimal code for 14, which is 0E. 0E for that note. All right. And so on and so forth. So if we're looking at sending like MIDI note, here we're in the C3 range. So let's say we're G3, which is MIDI note 43. The hexadecimal code for 43 is 2B. All right. Okay, now let's take a look at where this all comes into play here. I'll get these graphics out of the way. So what I have here is a software piano keyboard. So I'm going to be able to play back notes on this. And this is a piece of software which I highly recommend, which is called MIDI Ox. This has gotten me out of a lot of different jams because I'm not only using MIDI to do show control, but I'm also troubleshooting electronic keyboards that are in the pit orchestra and trying to figure out why they're in what octave and what's happening there, and we're using controllers. So a lot of times it was trying to determine, okay, am I getting a MIDI signal from a device? And what is that MIDI signal I'm getting? Why isn't it being recognized? It can also help you with QLC Plus if you're getting can't figure out why a particular MIDI signal is not being recognized. This can help you out. So I'll put a link to this in the description down below. It's a fantastic program. It's free. It's called MIDI Ox, and it basically will show you what kind of MIDI information is being transferred here. So it helps you to troubleshoot a lot. So right now I have my input window here. And by the way, I'm also using a program called LoopB, and that runs in the background here. I will give you a link to that in the description also. It's basically a virtual MIDI cable. So this is one MIDI device and this is another MIDI device over here. So I have to link these two together using a virtual cable so that this piano keyboard will talk to this software over here. And we can actually look, if I click on here, it will show me my MIDI coming in is LoopB internal MIDI, because when I'm playing this keyboard here, I have it set up to send out a signal through LoopB. So it's coming in, and then I'm sending a signal out from this to the built-in wavetable synthesizer that's built into the software of every Windows computer. So it's going to be sending a MIDI output signal to the Microsoft GS wavetable synth on here. And I clicked OK. Just a note on this. When you're using LoopB internal MIDI, never have your input and your output going to LoopB internal MIDI. What it will do, it will create a feedback loop. Just like you have an audio feedback loop holding a microphone in front of a speaker, you'll create a MIDI feedback loop that will be continuous. And in order to protect itself, what will happen is that LoopB down here will mute itself. And that can cause some issues. And then you're trying to troubleshoot and finding out why all of a sudden QLC Plus is not receiving MIDI messages. It's because LoopB might have muted itself. So double check down here to make sure that you don't see kind of a symbol here, and it'll have a red symbol on it that it has muted itself. You can right click on this and unclick. If it's checked as muted, you can unclick muted once you've solved the problem here. But make sure you don't put input and output to LoopB, or it will create that feedback loop and LoopB will automatically mute itself. Okay, just a word of advice there. Okay, so I'm going to play some notes on our MIDI keyboard here and see what kind of messages are generated. Now notice when I press on the key, I get a message generated, a note on message, and then when I release the key, I get a note off message generated. Now, there are three parts to this message, and here they're going to show us the hexadecimal code. Over here is a translation for us to look at of that hexadecimal code. So there's three parts to this. Part number one, the number 9 tells me that this is a note on message, and the 0 tells me that this is being sent over MIDI channel 1. So let's take a look here. There are different types of messages that can be sent. If you see a number 9, that is a note on message. And if you see a number 8, that is a note off message that's being sent. The number after that 8 or 9 is telling us what MIDI channel is being sent on. Now, there are 16 MIDI channels, and they are numbered as 0 through 0F. So this is where it's a little bit confusing. This would be MIDI channel 1. So you would use hexadecimal 0, and you only need the 1 0 for this since we're only going up to 16. MIDI channel 2, you would see a number 1. MIDI channel 3 would be a number 2. MIDI channel 4 would be a number 3, and so on. So MIDI channel 16 will be an F. Right now, if you look up here, I am broadcasting on channel 1. I'm using MIDI channel 1 to send the message. If I change this and increase it, and notice I'm getting some MIDI messages up there, Now I'm going to go to MIDI channel 16. Now if I send the same note, notice that now it says 9F because it's still a note on message, but now it's being sent over MIDI channel 16. And then the note off message is being sent the same way over MIDI channel 16. And notice the translation over here too. When we started changing all of our channels, it told us. So in our translation, it's telling you this is message is being sent on channel 16. The note that's being sent is a C6, and it's a note on message or a note off message. Okay. Now let's just take a look at some more information. I'm going to move this back to MIDI channel 1. And I'll just clear out my monitor here to make it easy to see what's going on. Play this note again. So there we have our 9-0. So it's a note on message on channel 1 and then a note off message on MIDI channel 1. Now the note that we're playing is note 54. Now remember, this is hexadecimal. Hexadecimal 54, so let's look at the chart. So hexadecimal 54 is all the way over here, 54, which is actually note number 84. Now let's take a look at the note chart. Note number 84 is right here, so that would be C7. C7. So again, explain that. It's hexadecimal 54, which is actually number 84. Now, if we look at note number 84, it's C7. Now, something interesting here. C7. Let's take a look at what was displayed. It says that this is note C6. Remember how I told you that different manufacturers can do different things or have different designations? So in this case, let me bring back up my chart again. They're considering this C here not to be C0, but C-1. And then this would be C0, C1, C2, C3, C4, C5, and C6. So you will see that. I've even seen some manufacturers that designate this as C-2, C-1, C0, C1. So again, this is where MIDI Ox is going to help you identify by looking at the hexadecimal number for the note, that you won't get confused with this C-1, -2, C0 thing. You can actually kind of zero in on, okay, what's the actual hexadecimal number for the note that's being sent. That can get you out of a lot of jams when you're trying to figure out this C0, C-1 thing. The final piece of information here is velocity. So this is how hard I am playing the key. So the MIDI keyboard can, by playing the key harder or softer, you can change the volume of the note. That's the velocity of that. So this particular keyboard is set up, since I'm using a mouse to pluck the keys, I can't really control the velocity. If I was playing on an actual MIDI keyboard, I could control that velocity by playing the notes harder or softer. But up here with this software version of a keyboard, it's just going to send out the maximum velocity level all the time, which would be 127. In MIDI language, 127 is hexadecimal number. Do you remember what it is? 7F. So it's basically saying that we're playing this at the loudest velocity, which is 127. So they're using the number 7F to designate that. Okay, so once again to recap then. The 9 means it's a note on message. 0 means been setting on MIDI channel 1. The 54 is the hexadecimal code for the note that we're playing. And then this would be the velocity. Notice for the note off, we have a velocity of 0 because a note off is no velocity. We're not turning the key on, we're releasing it. So this would be note off command, channel 1, the same note 54, and then this is 0 velocity, and it'll give you that information. Now just a little piece of information that is very important. If you're going to use note on commands to push buttons or to initiate some kind of an action on either a piece of hardware or in QLC Plus that you're using it to initiate a button push. You must also send a note off command after you've sent the note on command, because here is the problem. When you send a note on command, the computer that's receiving or the device that's receiving the command says, okay, you sent me a note on command. If you try to send another note on command, the same note, without first turning it off, it's just going to be ignored, because the device or the computer is going to assume that you already sent me that note on command. So just keep that in mind. If you're going to use note on command, you should always follow with a note off command. Basically, QLC will see this and just ignore this part of it, but then you're able to send this command again, because in general, the computer's looking at this and saying, all right, you sent me a note on command and a note off command, so I can receive that command again. So just keep that in mind. Another piece of MIDI information that you can use to control buttons is what is called a MIDI program change. So I have my keyboard. If I go to change the program on this keyboard, and maybe right now I'm on acoustic grand piano, and I go to honky tonk piano, notice that we have a different type of message that came up here. It says CF. CF is a program change. And they'll tell you right over here, our program change has been honky tonk piano. If we look back here at our MIDI codes, C is a program change message. So when you send C, that's a program change message. You could use the program change message to send information to QLC Plus to press certain buttons. Notice with the program change, there is only two pieces of information here, okay? It's a program change message, hence we have the letter C. It's being sent on MIDI channel 16. We could change this back to MIDI channel 1. And I'll send a program change here on MIDI channel 1, C0. So it's still a program change. It says acoustic grand piano. And it's telling you this is program change 0. So that would be referring to that particular program change. It's program change on MIDI channel 1, and it's program 0. If we pick out some of these different programs on here, let's say we want to go trombone, program change, MIDI channel 1, program change 39. And it tells you that this is a trombone program. But you could use this MIDI information to actually trigger buttons on QLC Plus, or on other devices like the Behringer mixer or something like that, or like a lighting board to send it a go message. When you're using QLC Plus and you're changing sliders on QLC Plus, now that is what we call a controller. So that's a different set of MIDI information. Right up here in this keyboard, we have some controls, and control number 7 happens to be the volume. I'm just going to pick out control number 1 as modulation, and this is my wheel here to change the modulation information. Notice as I'm moving this wheel, I go all the way from, okay, and this is going to be B0. That's going to be a control change. If you look here in the MIDI code, B0, B is a control change message. So it's looking for a control change message, and then I'm gradually adjusting it, and it's telling you it's controller number 1, which is the modulation, and then I'm gradually adjusting it from 0 all the way up to 7F. And I'll try to move this. Let me clear this out for a minute. Now, as you'll see, if I move this, I'm starting at 0, and you'll see data 2 is where I'm at. So if I go all the way up to 127, there I'm at controller channel 1. It's controller number 1, which is modulation, and now I'm at the maximum value of 127. So this is where you use this controller information to move your sliders on QLC Plus, or to move your sliders like on a mixer, if the mixer does understand the commands. And again, it all depends on what the manufacturer's baked into the hardware, or what's baked into the software. QLC Plus will understand these controller information, so you can use controller information to control faders in QLC Plus. And so you have a whole bunch of different controllers that are available here. They only list some of them, but there are up to at least 100 different controllers, if not more, 127 different controllers. So I can go, for example, let's go to volume. And you'll see that now my controller is number 7. So I'm still doing the controller message on channel 1, but now it's talking about controller 7. And now I can adjust this up all the way to top to 7F. All right? So that controller information can be used to control the faders or sliders in QLC Plus. All right. Hopefully this helps you understand a little bit more how the whole thing's working. I recommend this program here because it gives you a visual of what's actually happening. And a lot of times what I'll do is if something's not working in QLC Plus, I'll bring up this monitor just to see if the messages are coming in to the computer, and then try to figure out, okay, why is QLC Plus not responding to this? Or why is my light board not responding to this? Or why is my mixer not responding to this? It's just fantastic for troubleshooting.